Alright, part 2c, we want to find the time at which the speed of the particle is 3. And we know that speed is equal to the magnitude or absolute value of velocity. And the magnitude of a vector is pretty much solving the Pythagorean theorem, where this is the horizontal leg of a right triangle, this is the vertical leg, and the hypotenuse, so the distance from the corner to corner of this, is going to be that. So, or you could memorize the formula, either way. So it's going to equal the square root of this squared. So I have cosine squared. Actually, let me write it this way. This is what I'm going to write in the calculator anyway. So cosine of t squared plus e to the 0.5 t all squared. And I could, write this as cosine squared and multiply the 2 and the 0.5 and get e to the t. It doesn't matter. I need to find the time at which this speed is equal to 3. And so again, this looks like a little bit of a mess to solve. I could square both sides, get a 9 over here, but I'm just going to go straight to the calculator, write this in for one of my functions, so I still have the work here from part B. So I'll put this in, the square root of, we have the cosine of x. There should be a squared in here. So cosine of t squared. Go back to here. So x squared. Close that off, squared. Plus e to the 0.5x squared. Okay. And on the other side, I'm going to put a 3. Graph them. Let me do a window here. So let's do a zoom standard, see what we get out of there from negative 10 to 10. Of course, we don't really care what's happening negative because it's not defined on the negative side. But this should be good enough to see right here is where we intersect. So I can do second calc, intersect. That looks about right. My first curve is this big old square root, which is the magnitude of a vector. My second curve is 3. There's my guess. And I get that t is approximately 2.196.